Now we can get started. Now, here we are working on this week here, and ideally what you've done, it would be ideal if you had gotten started on chapter 7.2 already. And here's why. Let me get over here to the my StatLab website and go to the learning modules and learning module 11. Now, the most important thing, most absolutely important thing in this module is, the lessons are good with the lecture notes, but what you really need to do, especially since it's an online class, is this movie. This movie will step you through the whole procedure, all the steps that you should be taking in order to be learning all these fundamental skills that we're going to build on and that are going to help us a lot later on. So now, after you watch that movie, we've got, and of course, you got some practice exercises, but what I'm going to be doing today is these are the steps that I'm going to be doing. And notice that you can always come back to this, and this covers every single little step. In particular, see this, what I call the probability inequality notation? That notation replaces an entire sentence. And to get good at making this, you use the sketch. So I'm going to be demonstrating that. But the sketch helps you on so many different levels. It's the most important thing you could always be doing on every problem is always make the sketch. And so you'll notice I'll be demonstrating that. So let's set that off on one side there. And I don't think we need this anymore. And we will get over here. Now, after seeing that movie, you've got this document that just reminds you of the steps. First watch the movie, get to sink in, but then sort of use this as your little template, your little reminder. Don't forget any of these steps as you do every one of these in the part 1 for this chapter 7.2. So that's what I'm going to be demonstrating. So just know that it's all documented here. And so it would be ideal if you've already done that. Then after we do this, then I'm going to be covering what we'll be doing in the second half of this week when we get to part 2. Now, very important. Before starting part 2, you need to be really comfortable with part 1 first. So don't be surprised as if I'm doing part 2 and you really haven't had time to do part 1 yet, you're going to have a little harder time following along. But I assure you, after you've mastered part 1, you'll be ready for part 2 and make more sense. But hey, that's why this is being recorded. So you can come back to the part when I'm talking about part 2 when you're ready for it. But who knows, maybe you've already covered part 1 well and you won't have any trouble at all. Okay, so let's set that aside. So what we're going to do is do some of these problems. And let's see here, something. Oh, somebody's saying they can't hear anything. Is that true for everyone else? My microphone is on. So I'll just type to everyone. Can everyone hear me? If you can, okay, good. And if anyone can hear, go ahead and speak up so that way Vanessa knows that something with their microphone or headphones. Okay, well, this is being recorded, so Vanessa will be able to come back and once that's figured out. Well, thank you for the feedback, letting me know. Okay, so what we're going to do, let's do some practice problems and go through the logic and the steps of it all. Now, this is what you're going to see this entire week. This entire week, we are always going to be given these 3 things. And this is the way to think about it. Think, hey, everything is going my way. Because what's our favorite shape in the whole wide world? In statistics, the normal distribution. And why we love it so much is there's no skew, there's no outliers. So we get our first choice for center and spread, mean and standard deviation. And not only that, we're going to tell you what they are equal to. You couldn't ask for more, because what you're going to learn this week is, wow, when you know these three things, just think of all the other things I can find out. In essence, I can find out everything else about that population if I know these three. All right, so first thing you do when you know these three things, take your mean, put that in the center. Then I'm going to go over to my calculator here. And we've done this before with the empirical rule. But it's very helpful to have this summary. And so in this part 1 homework, I highly recommend you get all the numbers underneath. Now, you got different ways to do it. You know, one simple way is you just take 74 and you just keep adding the standard deviation to it to get each of the numbers on the tick mark. So there's that one there, and then add another 8.7, get that one, another 8.7 to get this one. Take 74 and subtract 8.7, and from this subtract 8.7, and so forth. You can always do it that way. Of course, the way you might recall I do it is the way the empirical rule pretty much describes the intervals. So I take the mean and I'll subtract 1 and then in parentheses put whatever the standard deviation is. And then I hit enter, and then I start using the memory feature on my calculator. I press the second key and enter key, and I use my arrow key to highlight the subtract and change it to plus. And then I say to myself, look what I know about this population. I know the middle 68% is between 65.3 points and 82.7 points. And these are exams on a test. And then we just press the second key and enter key, and then we'll just change that +1 to -2 or subtract 2. Press second enter and change the subtract to plus. So it goes pretty fast. And then I put in the numbers. Let's see. Oh, good. Glad to hear that, Vanessa. Got to figure it out. Great. And then, of course, I would do the same thing going out 3 standard deviations. So it doesn't take long to put those numbers. When you do it, like this one, say, hey, I know the middle 95% of these exam scores are between 56.6 and 91.4. And also remember, that's the middle 95%. Think of those as the typical, usual exam scores. And you could say, you know, for this population of exam scores, getting below 56.6 is unusually low. It's only 2.5% are that low. And getting a score higher than 91.4 is unusually high, because only 2.5% of the population got one that high. So always, always run that summary through your head. Now, I was speaking in terms of proportion of the population being this interval. Well, it turns out you can also state that as a probability. And that's what you're going to get practice with this whole week, interpreting the area as a probability. The idea is this. If I were to randomly select just one from this population, what's the probability that one that I randomly selected is anywhere between 65.3 and 82.7? And the answer is 68%, approximately, rounding off to the whole percentage. So that's what you're going to practice. And that's what we're going to do now. Now let's see here. So they want us to find the proportion of all these exam scores that are greater than 95 points. Now, where is 95? Well, it's somewhere between here and here. Well, here's what we're going to do. You learned of a very handy tool that we're going to be using a lot in this class, and let's take that 95 points and standardize it into a z-score. So that's what we're going to do. I'm going to get my annotation tool here. So we've got our z-score, just like you calculated on your exam 1. And going to see how far my data value deviates from the mean, and then divide that deviation by the standard deviation. And so we do that. So we got our 95, subtract the center, we see right here 74, and divide by the standard deviation at 8.7. And then we're just going to go over to our calculator. Let me clear all that off. And left parenthesis, 95, subtract 74. Hopefully you know why it's important to have the parentheses, because of order of operations. We'll get a wrong answer if we don't use those parentheses. So we knew it was somewhere between this tick mark and this tick mark, but now I know it's 2.4 standard deviations. Well, that's good to know. That makes it so much easier to locate. So that's what we're going to do. I'm going to, so there's 2, and there's, it looks like 2.5, so it's a little less than that. So I'm going to eyeball it right about there. So right there is where the 95 is. Now, listen, what you do is you draw a line. So wherever you landed, draw a line where that point landed. Then you're going to ask yourself, because they just gave us 1 point, so that's either a lower bound or an upper bound. So I need to know, do I shade to the right of this or to the left? Well, you read carefully. It could be one or the other. They said all the exam scores that are greater than. Well, where are the exam scores that are larger? Well, hopefully you're familiar with number lines. If you're not, then you probably really haven't met the math prerequisite for this class, that you at least know larger numbers are off to the right. So it's that little area there. Of course, this does go off to infinity, but you see it's a pretty small little area, isn't it? Now, let me show you how I can use this sketch to help me convert this sentence into that probability inequality notation. See, I got my 95 right there, and all the x values, data values, are off to the right. Since they're off to the right, just put your x off to the right. Leave a gap in between. And then looking at these two, you know, whoever's farther to the right is the bigger, larger value. So it gets the big end of the inequality. And of course, I explained why it looks like this in that movie. So if you haven't watched the movie, make sure that you do. Put parentheses around it, a capital P in front, and that notation replaces this whole sentence. You know, if I were to interpret this, here's the sentence. And here's another way to interpret that. You know, this is the proportion of all the exam scores that are greater than 95. And you can also interpret this as the probability of one randomly selected data value being greater than 95. So that's pretty compact, isn't it? Nifty compact notation. So once we got that, now the job is to find that area under the curve, because that's what we're asked to find. Well, I don't know if you're aware, but there's a pretty wild function or equation that defines this curve. And there's a certain branch of mathematics that finds the area under a function but above the x-axis. And that's called calculus. Well, our calculator's going to do the calculus for us. Now, fortunately for us, we got everything we need right here. With the understanding, we know what the center is, we know what the spread is. And you've got a little template, so let me write down the template. It's called Normalcdf, and it just needs 4 inputs. It needs to know the interval, and an interval has a lower bound and an upper bound. That's what makes it an interval. Well, the lower bound's pretty straightforward. That's our 95. Remember, your lower bound is always what's on the left side of the interval. The upper bound is always on the right side. We do a comma. Now, what should I do for an upper bound? Well, really, anything that's way more than 100. Now, just going to 100.1 is not far enough. You need to go way farther. So anything way off to the right is going to be just fine. Now, I think in the movie I show you how you could just go hog wild, using scientific notation, well, one with 99 zeros, but you don't have to do that. What if I just put in 1,000 here? Because of my sketch, I know there's an infinite number of values way off to the right, and 1,000 be way off to the right. That'll work. But now we then put in our center and then our spread. Now be sure and just refer to the template, because it'll be on your formula sheet on the exams. Because you've got to put it in this order. You change the order, you got yourself the wrong answer. But it's pretty logical, because in your interval, first you got your lower bound, then your upper bound, lower bound, upper bound, and up here first you have your center, then your spread. It's the most logical order in the world, but we don't expect you to memorize it. But Normalcdf, it's important for you to remember, so you're ready for when you get to part 2. What it gives you is the area under the curve, which can be interpreted as proportion of the population in this interval, or the probability one randomly selected in that interval. All right, now on your calculator, how you get this, you're going to press the second key, and then you'll press the vars key. So that's what I'm going to be doing next. Oh, and then after you do that, you'll choose choice number 2. So let's do that and enter this in. So let's turn that on, and I'll just press clear. So you press the second key. The vars key is right here to the left of the clear key. And it's choice number 2, so you can just press the 2 key. And then you do your inputs, your lower bound, 95. The comma key is right above the 7 key. Then anything really big, whatever you want to use that's really big, way more than 100.1, comma. Then we put in our center, which is the population mean, comma. Then our spread, which is the population standard deviation, 8.7. Right parenthesis, that's above the 9 key, and hit enter. Now, when you made your sketch, you knew it was pretty small, didn't you? So you have a rough idea of what to expect. Yeah, that is pretty small, but I had a small area. I was expecting that. So that's why it's another reason why it's very helpful to have a sketch. So we'll say that this is equal to, I'll do the decimal format first, 0.0079, rounding off, and turning that into a percentage. Well, multiply that by 100 and you'll have it as a percentage. Well, multiplying this by 100 moves the decimal point 2 places to the right, so that would be 0.79%. So that's less than 1%. That's a very small probability. And our general rule is, if a probability is 5% or less, then we say it's small enough to be an unusual event. So we'll say, hey, it would be an unusual event to randomly select one of these exam scores and it being larger or greater than 95 points, because the probability is so small. Okay. So that's what you do, is once you get the answer, you've got this notation. When you got the notation, be able to put this into words. How do you put in words? Well, we'll say that there's a 0.79% probability of one randomly selected exam score being greater than 95 points. And we'll say 79% of all these exam scores are greater than 95 points. So those are all the steps that you're to do for every problem you do. And you don't have to worry about forgetting if you just refer to that template that I just showed you, that's available to you in the learning module. And one thing that'll help prepare you for part 2 is do this. Oh, and there is something else that I want you to do. They haven't done yet. So this is equal to 0.79%. And it's also helpful. Go to your sketch. Now, whenever I'm referring to the numbers here on the number line, I always do those underneath. If I'm talking about an area under the curve, I always do those above to help keep straight which numbers are which. Because that's your big battle, is keeping straight in your head which numbers are areas under the curve and which numbers are points on the number line. Because unless you're super clear on that, you're going to get confused when we get to part 2. Now, so that's why it's helpful, putting that right there and in your sketch. But be able to do this. Make a note that, look, they gave me this interval, and I use Normalcdf to get the area under the curve. And remind yourself, this number is the area under the curve, which is a probability or proportion, and inside the parentheses is my interval. And your interval has either a lower bound or upper bound, lower bound in this case, which is a point on the number line. It's a data value. So, here's the funny thing. You think that the point of doing the homework is to get the answer. But you know what? That's not the real value. The real value is all the concepts you learn in the process. And that's why you don't want to go through the homework mindlessly. You want to run all these concepts through your head, because that's the most valuable thing you're getting from it. Because these are all the concepts we need to master in order to understand inferential statistics when we get to it. We're laying down the framework this week and next week. So don't skimp on thinking through the logic of every step. And that's why I give you the template to make sure that you can check yourself, make sure you're doing that. For my really good students who really do want to learn this well. Now let's go ahead and I'll get my clear my scribblings there. We'll scroll on down. And so here you can, now by the way, you're going to have access to this document afterwards, and I'll be showing you where you'll be able to find it. So there you can see a nice writing. By the way, might seem in the future, but when you get to exam 2, but even before that, even when you're just doing the homework, when you do the homework, you'll notice that, let's get over here, that you've got these text from the textbook that's available from my stat lab, these exercises, do those, and then check your work with these solutions. Do this before you start the online homework. This helps you prepare, and it's a learning process. Make sure you're doing it right. These are detailed solutions. And then even though you're doing the homework online, you should still use paper and pencil, do all your work, making the sketch, going through all the steps we're doing here, and then you just punch in your answer. But always, always go through all these steps with paper and pencil on every one you do, because that's the whole point of doing it. Now, let's look at another one here. Hey, it's the same population. Yeah, but we got a different question now. We want to know the probability of one randomly selected exam score from this population being less than 59 points. Then we can determine if that's an unusual event or not by looking at the probability. Okay. And another way, now remember what a percentile is. The percentile tells you the percentage of the population that's below or less than that data value. Well, then we could also say the percentile rank for the exam score of 59 is the proportion of all exam scores that are less than 59 points. So you got 2 ways to say the same thing. So this was, percentile, that question was on your exam, so hopefully you've learned it already. If not, you're going to have to learn it because you're going to be seeing it a lot here. You just got to remember percentile's area to the left. So if you've got a point, the area to the left is the percentile rank because it's the proportion of the population that's below. So that's why it's so important you're able to interpret the area under the curve so you can see that these are the same. But where is 59? Well, it's somewhere between here and here. And how are we going to make it easy to locate it on there? Well, you probably already know what we did last time. If you want to z where it is, we do the z-score. And so we'll take our data value of 59, we'll subtract the center, which is 74, and divide it by the spread. And let's see what our calculator says about that. So we got 59, subtract 74, divide by 8.7. Okay, so that's 1.72 standard deviations below the mean. Well, that certainly makes it easier to locate where it is. So let's do that. So there's 1.5, 1 3, that's about 1.75, so it's a little less than that. So probably right about there. That's pretty close. So that right there is where the 59 is. So what do we do next? We draw a line there. Then what do we do next? Well, essentially, we're asking ourselves, which way do we go, George? Which way do we go? To the left or to the right? Well, let's read carefully and see what it says. They say all that are less than. Well, less than are to the left because those are the ones that are smaller. So we're going to shade in the area off to the left. So it's going from 59 off to negative infinity and beyond. All right. Hey, so let's use our sketch here to do that nifty probability inequality notation that replaces these sentences. So, got the 59. Where should I put the x? To the right or to the left? Well, we shaded in the left, so that's our x's. So we put x to the left. The shading tells us which side it goes on. Now you know whoever's farther to the right gets the big end of the inequality, who's smaller gets a small pinched end. Put parentheses around that, capital P in front, and there's the easy way to get this notation that represents all three of those sentences. Now, what we'll do is we're going to use Normalcdf. Now, what to do for a lower bound because it's negative infinity? Well, as long as you're going way off to the left, way to the left of 47.9, you're good. Well, 0 would work, and you can go out way farther in that. But 0 will definitely work because that is way off to the left here. And that's the benefit of having all these numbers on here. Now, our upper bound is the 59. So hopefully you're noticing how easy it is to put these numbers in here with the sketch. I can see what would work off to the left. I can see what the upper bound is. I can see what the center and the spread is. And now we're ready to punch that into our calculator. So we press second, vars 2. And whatever lower bound you wanted, put that in, comma, and then a 59, comma, 74, comma, 8.7, right parenthesis. And then we can hit enter. And that makes sense because we knew that from this tick mark to the left was 2.5%, so we knew it had to be more than 2.5%. And this seems reasonable, 4.23%. Here, I'll go ahead and first write it as a decimal and then as a percentage. So we got here 0.0423, which equals 4.23%. Now, just to emphasize in our minds what that number means, go to your sketch and when it's an area, do those numbers up above, and when you do numbers below, make sure they're only the data values, numbers on the number line, just to help you keep it straight. 4.23%. So this notation here, this is the probability of one randomly selected exam score being less than 59 is 4.23%. Is that small enough to be considered unusual? It is. It's less than 5%. And 4.23% of all these exam scores are less than 59. So 59 is at the 4.23rd percentile. If you want to round to 4%, I guess you could, but 4.23rd percentile if you want to go out to 2 decimal places in your percentage. All right. Okay, and so it looks like we've covered all the bases. All we could do is remind ourselves we were given the interval, and we used Normalcdf, and it gave us the area under the curve. And so those are the steps you want to go through on each one of these. You can see those. Now listen, now these are common mistakes, we make when we're learning. And if you make them, just learn from them. But just to give you a heads up, forewarning. Now, when your interval goes off to negative infinity, and listen, because you notice I didn't do this, but on this previous one, let me just go over here and do it that way. I could press second, vars, Normalcdf. Now, I could do the -1 E99, but you got to use the key to the left of enter. -1. Then I had to press the second key and the comma key. See how that little E is, and then the 99. So that's a scientific notation. -1 times 10 raised to the 99th power. In essence, -1 followed by 99 zeros. So that's always far enough to the left because it's so outrageous. Okay. And then, of course, I'd go ahead and do all the others. 59, comma 74, comma 8.7. And hopefully you see it's the same answer. But sometimes what can get people in trouble here with this one, let me just press second enter so we get it back again, is they forget to put the negative in there. Well, if you do that, your lower bound is bigger than your upper bound. Well, if you get things backwards, and things aren't quite, well, you didn't necessarily get it backwards, you just left out the negative sign. But if you were to get your lower bound, upper bound backwards, what does your calculator do? Does it warn you that you've done that? Nope. It tries to make a fool out of you by giving you a negative probability. And if you write down a negative probability, you'll be the laughing stock of the statistical community. Isn't that cruel of your calculator to do that? Gosh, because remember, probabilities are never negative, and they're never larger than 1. They can only be from 0% to 100%, or 0 to 1. So that can't be. So if you get an impossible answer, look at your interval. That's where your problem lies. 99.99% of the time, that's where the problem is. Okay, now let's see. So it's warning you about that. Oh, the other thing is, now, when you want to do a negative number, don't do the subtract key. Like if I want to punch in -1, I do it like that. But if I do it wrong, I hit the subtract key. What happened here? Well, it says, oh, we're just going to take your last answer and subtract whatever you put in next. Oh, well, that wasn't what I wanted to do. Well, that's what. So you got to remember, this is for negative numbers. This one is for subtraction. Oh, and I think the worst, most tragic mistake you could possibly make is thinking that making a sketch is a waste of your time and just causing you to do unnecessary work. But the thing is, and hopefully you notice this, is that it helped me every step of the way. And I'm telling you, I've been teaching, statistics for decades now, and I assure you, students who don't make sketches are miserable wretches. They really are, because they're so lost. And they'll never blame it on their lack of doing sketches. But the sketches will prevent you from ending up like that. So watch out for that. Oh, and also notice this. Once you get the answer in your calculator, you're not done. Notice all the concepts we ran through our head after we got the answer, because we were interpreting that answer as a probability of one randomly selected being in that interval, and as a proportion of the population being in that interval. And if perchance it was area under the curve, also, let's see here. Yeah, area under the curve. I got distracted. I was looking at my other monitor here, and I said the chat, and I just realized, oh, that's because I didn't look at them there. I did check them. So I just got distracted. But let's go now, taking it to stage 2. Now, the deal with that is, let me get my annotation tool here. So what I want to emphasize, we were given the interval, we gave that to Normalcdf, and Normalcdf gave us the area under the curve. Well, what we're going to do in part 2 is they're going to give us the area under the curve, and we're going to find the interval. Why, that's the inverse of what we just did. And that's why we call the function inverse norm. But what's so important is that's why we've been stating these two interpretations. Because when they give me this area, how will I recognize it? Because I practice this. Because I'm used to stating this as the probability of one, as a proportion of the population, because that's what they're going to be giving me. They're not going to give me the interval. They're going to give me the area under the curve and expect me to find the interval. So you want to learn how to do something going forward really well first before you start learning how to do it backwards. All right. So if you haven't spent much time on part 1 yet, just hang in there with me as best you can, and just be reassured this is being recorded, so you'll be able to come back to it after you have really mastered part 1. So here we go, part 2. Set this one aside. Now for part 2, what you have, it's very important that you use this template that you have available to you. That's from the learning. Oh, let me clear my drawing first. There we go. And the steps you do are very different from what you were doing in Normalcdf. That's why you really need these templates to really guide you for, through the first several exercises you do before you are able to remember it. And I'm actually giving you a more challenging one here, so we'll start off an easier one. But I just want you to know that all these steps are all documented in here that I'm going to be doing here in this session. So you've got this for a very handy reference. Here's an image that you should probably have posted up somewhere, because it'll help you keep the big picture straight in your head that you'll be doing this week. Because look, you're going to be given one of two things. It's one or the other. Either they're going to give you an interval, points on the number line like we just did, or they're going to give you an area under the curve. Okay, so let's suppose, and one might remember, it's only one or the other. Well, in part 1, the focus is on this. What do? Well, follow the arrow. Oh, I use Normalcdf, and it gets me the area under the curve. Okay, but what if I was given the under the curve, like we're going to be doing now? What do? Follow the curve. You use inverse norm, and that'll get you the interval. All right, there it is, all summed up. The big fundamental picture. This is how you know whether you're going to use Normalcdf or inverse norm. It all depends what you were given and what you were asked to find. So to keep this, remember, this is in your learning module. It's called, all the steps for using inverse norm. So with that, oh, by the way, also available is I got templates in there. So you could print these up, and you got 3 big normal curves. Now the ones with the tick marks are ideal when it's a normal CDF problem, like the ones we just did. But if it's an inverse norm type problem that we're going to be doing next, we have ones without the curve. And those are without the tick marks. It's got the curve. I mean, it doesn't have the tick marks underneath. But here, let's take a look at this one. Now we'll do a little overlap here. He said, hey, this is the same one, isn't it? Okay. Well, same idea, but we're going to find the percentile rank for an exam score of 65. Why I'm doing this one is because quite often, if students are weak in an area, it's remembering what a percentile rank is, if they haven't done it yet. So they have to think, they first have to remember what a percentile rank is, and then they have to interpret it for their sketch, and they have to keep straight. Now, what is this 65? Is that a point on the number line or area under the curve? Well, that's a score on an exam. That's what our data is. So it's a point on the number line. And 65, it's, well, a little to the left of here. Oh, so in other words, this is going to be a normal CDF. Yeah. But we're going to gently lead into something here. So essentially, right now, I'm going to be doing just like what we were doing previously. I said, well, I better, to make it easy to locate right where that 65 is, let's turn it into a z-score. And we'll just punch that in. Just press the clear key, clear that out. Got 65, and we're going to subtract the 74 and divide it by the 8.7. And that seems about right, because we know it's a little to the left, and it really is. It's just a smidgen below one standard deviation. So we can go ahead and draw that in. Just a smidgen, just below it. So we'll draw a line there. And that right there is our 65. And then, in order to know which side we shade in, you need to know what a percentile is. A percentile is the area to the left. So that's how we know to shade into the left and not the right. Now, if you didn't know what a percentile was and you thought it was the proportion larger than, you'd be shading in the wrong region. And that would be a shame. Now, so our x values are to the left. 65 is to the right, so it's bigger, gets the big N. So there's the shorthand notation for what they're asking for, the proportion of all exam scores that are less than 65. We're going to use normal CDF. Now, in your work, especially on exam, always show the function you're using and the inputs. One, for you to document your work so when you look back at it, you know what you did. But on an exam, that's how you get partial credit, even if your answer's wrong, because you're able to show what you did correctly. Do you think I ever see on these exams where a student has everything written correctly in there, but they got the wrong answer? Yeah, but they're going to get almost all the points because obviously they knew what they're doing. They just punched the wrong button somewhere. I don't know, but it sometimes happens. Now, anything way off to the left, you could do your -1E99 or anything way off to the left. I'll just do the 0 because it's easier. And 65 is your upper bound. Put in your center and your spread. And we're ready to punch that in. So second vars 2. Whoops, I punched the wrong thing. Second vars 2. And we'll have 0 or whatever you had way off to the left. 65, 74, 8.7. And there we go. So it's about the 15th percentile, isn't it? Percentile rank of 15 is another way to say that. So that is equal to 0.1505, rounding off, 15.05%. If you want to round that off to 15%, you'd say it's at the 15th percentile. Why? Because 15% of the population is below it. Say, nope, I want to say 15.05th percentile. Well, you can say that too. You can always be more accurate. Nothing wrong with that. Okay. So what I want to emphasize here is, let me change my color and say that, look, they gave me 65, and when they said percentile rank, they told me it was the area to the left. So in essence, they did tell me the interval. And I used Normalcdf to get the area under the curve. All right, and so let me go ahead and clear that off. And here you'll see it done much more neatly written, typed out. Now, what we're going to do is, let's suppose, you say, Larry, where's your tick marks? You don't have the numbers underneath. Well, that's because they're asking us to find the exam score, in other words, the point on the number line that's at the 15th percentile. So what you got to recognize is, oh, they're telling me the proportion of the population that's to the left when they say 15th percentile. So that's why it was so important for you to know this definition and why it was on exam 1. Say, all right, they're telling me 15% of the population is to the left. So here's how you do with these problems. Start in the center. What percentile are you at there? 50th, all right? Well, I want to shrink from 50 down to 15. Which way do I have to go? To the right or to the left? To the left. So imagine a line here, and I'm moving it to the left. I'm not sure where exactly, but I'm just eyeballing it. And I'll say, well, I'm just going to say somewhere around here. Don't know exactly, but I'll just eyeballing it. And I'll just say that the area to the left here would have to be 15%. So there's a picture of the 15th percentile, where 15% of the population is below, and we're trying to find that point on the number line right there. We know the lower bound is negative infinity. We need to know the upper bound for this interval. So how do I find that? Well, this is a job for inverse norm. Okay. Let me write the template up here. Inverse norm needs to know just 3 things. It needs to know, first of all, it'll give you a data value on this number line. Which one? We say, well, you tell me the percentile rank for the data value you want. Well, the percentile rank is the area to the left. So you make your little sketch to see what the area to the left is for the point you want it to find. And then give it the center and give it the spread. So I can find this using inverse norm. What's my area to the left? Well, my sketch is telling me it's 0.15. And then what's our center? What's our spread? 74 and 8.7. So let's just go over and punch that in on our calculator. Let's press clear that off. So for this one, we got to press the second key in vars as we did before, but it's choice number 3 for this one. So press 3, and so the area to the left is 0.15, comma, or 0.15, you want to enter it that way. 74, comma, your center, then your spread of 8.7. Hit enter. Now, what's so important is to impress upon you what this number is. So, as I write it down here, What would not be helpful for you is to just write your answer and think you're done. That would be extremely dangerous to do. Oh, let me use a squiggly equals sign. So I'm going to round that off to 65. So what I'm going to do is, let's do our notation. So I know that this number right here is 65. All my x values are off to the left. 65's to the right, so it gets the big end. Put the parentheses around there, a capital P in front of it. So you see how I'm using my sketch to get this notation? And I know what this is equal to. That's what was given to me, the 0.15 or 15%. And then you can say to yourself, well, look what I just did. They gave me the area, and I used inverse norm to get this interval. You certainly did. It's just like that little picture we looked at. You're given an area under the curve. You follow the arrow, use inverse norm, and it gets you the interval. Yeah. So we really want to press upon your mind, inverse norm is giving you a point on the number line. It's either a lower bound or an upper bound for an interval. And here's the other thing that guide tells you to do, and you might think this is pretty silly, but I'm telling you, it'll make a big difference for you. Because after you write it this way, and I strongly encourage that you do, don't just stop here with the answer. Write it out like this. Because then you say, wait a minute, I could give this interval to Normalcdf, and it should give me this answer. Well, let's try it out. So you go to your calculator and actually do this. Press second, vars. Whoops, I pressed the wrong. Second, vars. There we go. Now choice number 2 for Normalcdf. Now let's give it this interval. Well, this is going off to negative infinity. 0 is far enough to the left. Feel free to go farther if you want, comma. 65 is the upper bound. Tell you what, instead of 65, why don't we do all the accuracy here and do this 64.98, etc. So that's what I'm going to do. I mean, it's so easy. It's just staring me right in the face here. It's not really putting me out too much to do this much accuracy when it's right there, right above me. It's very convenient. Then a comma. So that's your interval. Now just do your center and your spread. Your center is 74, comma, and your spread is 8.7. Right parenthesis. Now before you hit enter, do you know what the answer should be? Hopefully, yeah, 15%. Is it really, really close? It sure is. We just have a little bit of rounding. We had to round off way out here, so that's why we're so close. Now, if you do this, so this reinforces in your mind, that's right. If I'm given an interval, I use Normalcdf to get the area under the curve. If I'm given an area under the curve, I use inverse norm to get the interval. Now, if you do that on every single exercise, when you're done, do you think you're going to be one of those students who say, now, when do you use Normalcdf and when do you use inverse norm? I can't keep it straight. Those are the people who didn't follow these extra steps after getting the answer. So don't you be one of those miserable wretches. You know, make your sketch. Your sketch helps you do all of this. All right? So let's try another one. Let's clear my drawing here. Now we're going to find the cutoff score for the top 15%. Well, let's suppose that this is very interesting to you, because let's suppose, you know, you're going to be taking this test and you find out that whoever gets in the top 15% of their scores, those students get a nice piece of chocolate. It's like, oh, I wonder if I'm going to be in the top 15%. Hey, I wonder what the cutoff score is, because you got to get at least that score in order to be into that privileged top 15%. Well, you can calculate that only because you know these three things. So what you do is you start in the center, and So you know that to the right, we're looking at values that are larger, the higher scores. Well, 50% is off to the right. We want to shrink that down from 50% down to 15. So which way do I got to go? Off to the right. So the area to the right shrinks down. You're not sure about where it is, so you just eyeball it. And these are the top scores, highest scores, so we're shading in off to the right. Put an X there. And you know that this area right here is 15%. You want to find this point right here, and you're going to use inverse norm. But what does the first input? It's the area to the left. Well, we don't want to use this. This is the area to the right. So we better find the area to the left, which is not so hard to do. Take the entire area under the curve, which is 1, and subtract the area to the right, the 0.15, and you'll know what's to the left. 0.85. In other words, the data value we're finding is the 85th percentile, because 85% of all the exam scores are less than this. When you're at the 85th percentile, that means 85% of the scores are less and 15% or more, making it the cutoff score for the top 15%. All right, so we better give this 0.85 because it's at the 85th percentile. Put in your center and your spread. And we'll punch it in. Second vars 3 and 0.85, comma 74, comma 8.7. So about an 83. You've got to get at least an 83 if you want to be in the top 15%. Let's get over here and finish our work. So about 83, if you want to be more accurate, 02. I don't know if this instructor grades out to that much accuracy, but just in case, we can show that. So once again, so this point right here is the 83.02 if you want to be more exact. All our x values are to the right, so put your x to the right. So whoever's far to the right gets the big end of the inequality. So there's your notation, and you know what this is. You know what it's equal to is what was given to you, the 15%. And so you run through your head, all right, they gave me the area. I used inverse norm to find the interval. Why, by golly, I should be able to take that interval and give it to Normalcdf, and it'll give me the 15%. So we're just going to go ahead and do that so we can impress this into our brains. What does what? So it starts at the 83. Why don't I just put in all that accuracy that's right there, right above me, 0.0169704. 169,704, comma, then something big for the upper bound. Oh, like 1,000, that's plenty big enough, comma. Then put in your center, 74, comma, and your spread of 8.7. And we know what this will be close to. And it is very close to 15%. All right. Now let's go ahead and clear that. Now this is a middle percentage. Now what's the deal? Now when you're given an area under the curve, it can only be one of three ways. For like the first way is either entirely in the left tail, or is entirely in the right tail like we just saw, or it's perfectly centered in the middle. And so for this one, what I want to refer you to is that's the example I used in this one. So this was middle 90%. So what do? Well, you got to figure out, now remember, it's perfectly centered in the middle, just like the empirical rule. Remember, the middle 68%, the middle 95, the middle 99.7. Well, what if you want to know a different middle percentage from those? Well, you can do it, and you just use inverse norm. So let's suppose you want to find instead of the middle 95, the middle 90%. You don't know exactly where it is, but you know it's a little less than 2 standard deviations because it has to go, instead of being out here to 2, 95 would have to be in a little bit. But that's all you know. Inverse norm will find it for you exactly. But your sketch is critical here, because what you got to do is take the entire area under the curve, which is 1, and whatever the middle percentage is, subtract that from 1. So 0.9 in this example here. So the two tails add up to the difference. Whatever that is, divide it by 2. And that is what is in each tail. Oh yeah, this is 90%, this would have to be 5%, and this would have to be 5%, so they all add up to 100%. But this is very important you have in your sketch, because then what you do is, now I'm going to annotate this, is you're going to use inverse norm to find this one. Well, what's the area to the left? 5%. So that's why down here, your lower bound is inverse norm, the area to the left is 0.05, and then whatever your mean and standard deviation go in there. Then you got to use inverse norm again to find the upper bound. Well, what's the area to the left here? Well, we got 90%. Is that all of it? No. You also got this over here. Some people say, oh, you go all the way to the left? Well, that's what a percentile is, all the way to the left. So 90% plus 5% is 95%. So this is at the 95th percentile. This is at the 5th percentile. So that's why these areas are to the left. 0.95 for the upper bound, 0.05 for the lower bound. And if someone asks you, now why did you use those? You'll tell them the answer is in the sketch. Now make that sketch and you'll stop being such a wretch. You won't be so confused. I mean, someone who says, I have no idea how you got those. Well, they're not making the sketch, or if they are making the sketch, they're not doing a very good job of it. And then, of course, what's so helpful about this, every time I follow up with Normalcdf, remember I'm saying, all right, they gave me the area under the curve. I used inverse norm to get the interval. See, wait a minute, I should be able to take that interval, give it to Normalcdf, and it'll give me that area again. So that's what we were doing here, and that's impressing this on your brain. So that's why that last step that seems so silly is actually so helpful. Now, there's one other thing I want to talk about here. So I'm going to get over here to the learning modules. Let's see here. And right here, now this is learning module 11 in the lessons compartment. And there's this document called How to Standard Normal. Let's take a look at it. Now, the standard normal distribution is such that if you could take any normal population, and what if you took every data value from that normal population and you turn it into a z-score? What would the distribution of all the z-scores look like? It always turns into this. In fact, I should complete this a little bit. In that, let's do one more tick mark. There's your 3. One more tick mark, and there's your -3. Because those are z-scores. Because if you had a data value that was 1 standard deviation above the mean, you would have a z-score of 1. It would land right there. So these numbers are z-scores. That -2 means you are 2 standard deviations below the mean. So remember, we learned that. You were tested on that on your first exam. So that's how you interpret these. But notice that in all of these, whenever you see the Z, you need to know that the center, your population mean, will always be 0. You can see, because this is, of all your normal distributions, this is the easiest one in the world to put the numbers in because it's always these. And your spread, well, what is the length of each of those tick marks? That's your standard deviation. They're all equal to 1. Can't get more standard than that. This is your standard normal distribution. So if they're asking you to find an area under the curve for the standard normal, you're just going to locate that z-score they're asking about, figure out if you're shading off to the right or to the left. Sometimes they'll give you a lower bound and an upper bound, and you shade in between. And so you got your lower bounds, you got your upper bounds, and you know what your center and spread is always going to be. Let me clear that off. So this document will help you with that. And of course, those practice exercises will give you some practice with that too in the learning modules. Okay. But if you were wondering, where does it talk about that? Well, this document right here. So you notice here we're going to find out for any normal distribution, if you go 1.96 standard deviations below the mean and up to 1.96 standard deviations above the mean, what proportion of the population would be in that interval? Well, you punch it in, there's your lower bound, there's your upper bound. The mean is 0, standard deviation is 1 for the standard normal. And, oh, that's about 95%. Because what you learn is that when you go 2 standard deviations above, it's about 95%. If you want to be a little more accurate, it's not exactly 2. If you want to be a little more accurate, you could go out more decimal places to 1.96 standard deviations instead of 2. But isn't it true 1.96 rounds off to 2 if you're going to go to a whole number? But anyway, so I want you to be aware of this. It's in the learning module. And if you were to overlook it, you might be a little stymied when it talks about the standard normal distribution. Okay. So look at the interpretation here. We've got this, but there's a 0.62% probability that one randomly selected data value from, and this is what's so different from what we did earlier. This is not from a unique particular population like those exam scores, but this is from any normal population will be more than, we don't say just 2.5, we interpret that as the z-score it is. So we'll be more than 2.50 standard deviations above the mean. Because it's positive z-score, we know we're that far above the population. Okay, so anyways, this gives you examples on how to interpret that. And over here, you got a little picture of it. So once again, that's in your Learning Module 11 in the Lessons tab. Okay, well, that's what you're going to be working on, and I hope you'll use those guides to guide you along so that you'll be able to follow all those steps. Oh, one other thing I want to show you. I haven't got it made visible yet, but I'm going to. But what you'll be able to see is when you click on external links, you've got this when you want to join a session, this one for the links to the recordings. Of course, I'll have session 4 down here, but there's going to be another one here, and it's going to be allow you to access the documents that I share with you during these sessions we'll be doing from here on out. And I'll, probably have a folder for each of our sessions that we have from now on. So I'll have that up there by tomorrow for sure. So all the documents you saw me using today, you'll be able to access them. But this is where you'll find it. There'll be something called here, files used in the live lectures or something like that. Okay, so if you got any questions, be sure and start asking now before we close this session down. give you a second to type stuff if you got anything. Let's see. Nope, doesn't see. Oh, let's see. I got something here. What was the average score of the exam? So the average score is the population mean. So what you're doing is you're basically being given everything you would ever need to know about that population. So they tell you the shape of the data, normal. They told you what the average score of the exam was, that's your population mean. And they told you about typically how far all the other exam scores deviate from that on average, and that's your standard deviation. And with those three things, well, that's what you're learning this week is all the things you can find out if you know those three things about a normal population. Okay? Now you're going to find, because of all these steps that we're doing, it takes more time. I wouldn't say it's harder, but you do have to invest more time. But if you invest the time and go through all the steps, you're going to find, hey, I get this. I got it. Maybe it took me more time to invest in it, but it's worth it because it's preparing you for next week. And what we're covering next week is going to prepare you for the whole rest of the term. So you don't want to be skimping on any of this. You want to know it really, really well. Don't settle for a superficial understanding. Okay? So until next week, we'll see you then.